Hi everyone, welcome to Mathworld. In this video, I'm going to show you the solution for Cambridge International AS and A-Level Further Mathematics Paper 2 for May-June 2022, and the code is 9231/21. Okay, so the questions in this paper is exactly the same as 9231/22. Alright, so let's move on to question 1. Okay, question 1. The curve C has polar equation r equals to exponential 3 over 4 theta, whereby the theta is defined from 0 to alpha, inclusive both. Given that the length of C is S, find alpha in terms of S. Alright, so now our S, which is the arc length formula, it will be integrate 0 to alpha, because your theta is defined from 0 to alpha, square root of r squared plus square of dr over d theta, then integrate with respect to d theta. Okay, so integrate with respect to theta. So this is the formula for arc length of polar coordinates. So our r is exponential 3 over 4 theta. Therefore, your r squared is going to be square of exponential 3 over 4 theta. Okay, so according to the formula EA to the power of B, it will be EAB. So from here, I will just times in the 2. So it will be 3 over 4 theta times 2, which means the 2 and 4 will be cancelled off. Then you will get E 3 over 2 theta. That is our r squared. Now at the same time, I need to get my dr over d theta. So when you differentiate exponential, let's say m theta plus b, alright, so we are going to rewrite the whole exponential, and then differentiate mx plus b is going to be b. So now to differentiate, we have to apply this exponential formula. So it means that I will rewrite my whole exponential. Then when I differentiate 3 over 4 theta, it will be 3 over 4. Okay, so from here, I will substitute my r squared, which is the e 3 over 2 theta, plus square of dr d theta. So I'm going to square this. So it will be 3 over 4 e 3 over 4 theta squared d theta. Okay, so from here, I will get 0 to alpha, square root e 3 over 2 theta plus, now square of 3 over 4 is basically 9 over 16. Then the e square of exponential 3 over 4 theta, we have solved it here, which means it's exponential 3 over 2 theta. Alright, so now when you simplify this, it will be integrate from 0 to alpha. So when you look at here, since they are the same exponential, which means the coefficient for the first term is 1. So I will just add up two coefficients, which is 1 plus 9 over 16. Then you will get 25 over 16. So 25 over 16 exponential 3 over 2 theta with the square root. Alright, so now I can split into two terms. Square root of 25 over 16 is basically 5 over 4. So I will factorize this constant. And then square root of e 3 over 2 theta. So I will get e 3 over 2 theta. The square root means degree half. Okay, and again use this formula. Exponential a to the power b is EAB. So now I will times in the half to my 3 over 2 theta. Then I will get 5 over 4, integrate from 0 to alpha, exponential 3 over 4 theta, d theta. Okay, so this is the simplest form. Now we can easily integrate this exponential. So it will be 5 over 4, integrate exponential. Now integrate exponential mx plus b dx, let's say for example. Then here is e mx plus b. Then since this is integration, so over differentiation of e is the differentiation of the mx plus b, it will be m together with the plus c. Okay, so now I will use the same formula, e 3 over 4 theta over differentiate 3 over 4 theta, it will be 3 over 4. Then now with limits 0 to alpha. Okay, so now the over 3 over 4, the denominator here, I can move up. So when I move up, I will switch the numerator and denominator. So it becomes 4 over 3. Then multiply by the exponential 3 over 4 theta, where the theta from 0 to alpha. Okay, so based on this, I may cancel off the 4. Then I will get 5 over 3. So then now replace the theta by alpha. I will get e 3 over 4 alpha minus e 0. Okay, so don't forget that all this equals to s. All of these are s. So I will rewrite my s here. So now my s will be 5 over 3 times exponential 3 over 4 alpha. E0 is 1. Okay, now I'm getting this. When you look at the question here, you need to find alpha in terms of s. Means that your alpha should be the subject. Okay, no longer s as the subject. So what I need to do here is, firstly, move the 5 over 3 to the s. So it becomes 3 over 5s equals to exponential 3 over 4 alpha minus 1. So let the exponential of 3 over 4 alpha as the subject. So now I have to move the minus 1 to the other side. So I will get 3 over 5s plus 1. Okay, now to eliminate the e, we need to take ln both sides. So ln exponential 3 over 4 alpha equals to ln. Okay, so for this, I can combine to get the same denominator, which means I will be getting 3s plus 5 over 5. Okay, so now ln e is the function itself. So I will get 3 over 4 alpha is ln of 3s plus 5 over 5. So at last, my alpha, I just move back the 3 over 4 to the other side. So it becomes 4 over 3 ln of 3s plus 5 over 5. Alright, so this is the solution for this question, which is alpha in terms of s. Okay, so now question 2. Starting from the definitions of cos and sine in terms of exponentials, prove that cos 2x equals to 2 sine square x plus 1. Okay, so for this case, I will start from the right hand side. So 2 sine square x plus 1 equals to, okay, now for your information, this 2 sine square x plus 1 is same as 2 sine x squared plus 1. Okay, so the definition for sine x is basically half of ex minus e negative x, then squared plus 1. So then I bring in the square to the half first, it becomes 1 over 4. Then this square, this bracket, when you consider the square, it will be, okay, just use the formula, a minus b squared is a squared minus 2ab plus b squared. So now my a is ex. So when you square the ex, okay, now just for your information, you square the ex, it becomes e2x. Okay, so here I will write first term as e2x, then minus 2ab. So when you multiply these two terms, ex times e minus x, it will be e of x plus minus x because of the formula ea times eb. It will be ea plus b. Okay, all these are the rough work. All right. Then now, when you simplify, that will be negative 2 because this will be e0. E0 is 1. Then after that, you square the next term, it will be plus e negative 2x. Then close bracket plus 1. Okay, so now the 2 and half can cancel, 2 and 1 over 4 can be cancelled off. So I will get half. Then e 2x minus 2 plus e negative 2x. Okay, then now you need to show that it is cos 2x. For your information, So cos 2x is basically half of ex plus e negative x. So now I need to get the half, right, as the factor, which means instead of this plus 1, I need to make it to half as well. Okay, I need to factorize half from plus 1. That means I will be getting plus 2. This plus 2 comes from the plus 1 after I factorize half. So from here, at last, you will get half of e2x plus e negative 2x, which is cos x. Okay, so this is how we prove the identity. Right? So now B, find the sets of values of k for which cos 2x equals to k sin x has two distinct real roots. Okay, so now first of all, rewrite. Okay, since just now we have proven that, okay, sorry, this is cos 2x, not cos x. Because, right, how to get cos 2x? So basically, we know that, okay, mistake here, this is cos x. So if cos x is half of ex plus e minus x, so cos 2x means that this x must be changed to 2x. So all the x must be changed to 2x. Then I will be getting half of e2x plus e negative 2x. Okay, that's why I'm getting this result in the previous part. So now, since your cos 2x in terms of sin x, so I will replace the left hand side by 2 sin square x plus 1, which is a result from the previous part. So now I will change this to 2 sin square x plus 1 equals to k sin x. Then now I can rearrange it to get a quadratic equation in terms of sin x. So 2 sin square x, move the k sin x to the left hand side. It will be negative k sin x, then plus 1 equals to 0. Okay, so now when you factorize this, okay, no, the question is asking for find the k. We are not solving for sin x, right? We are solving for k. So when this equation has two distinct real roots, means that the discriminant must be more than 0. So which means I need to write down the coefficients for all the terms, right? So coefficient for sin square x is 2. Then coefficient for sin x is minus k, which means my b is minus k. Then the constant is 1. So now since two distinct roots, right, two distinct real roots, that means b squared minus 4ac is greater than 0. So now replace it. B is minus k, square it, minus 4. My a is 2, my c is 1, then greater than 0. So from here, k squared minus 8 is greater than 0. Okay, so when you need to solve this inequality, we need to change to difference of two squares. Alright, so that I can factorize it. So a squared minus b squared is a minus b times a plus b. That means the 8 must be changed to square of a number. So the easiest way is k squared minus square of square root 8. Then more than 0. And hence I can apply this difference of difference of squares. So I will get two factors, k minus square root 8. Right, because my a is k, my b is square root 8. Then k plus square root 8 more than 0. Okay, so of course the square root 8 you can further simplify to 2 root 2. So now you can write k minus 2 root 2, then k plus 2 root 2 is greater than 0. Now to get the final answer, we need to sketch the graph for this quadratic. K squared minus 8. So since the coefficient for k squared is positive 1, therefore it is a quadratic curve which has a minimum point. Alright, so now the horizontal axis becomes k. And the two intersection points here will be the roots of the equation. Which means when you let k minus 2 root 2 be 0, your k is 2 root 2. So 2 root 2. And the next one is k plus 2 root 2 be 0. Then here you get negative 2 root 2. Okay, so now final answer is based on the inequality. This is more than 0. So since this is more than 0, you should refer to the region which is above the k-axis, which means it will be these two parts. So it means that you will accept the values greater than 2 root 2, which is on the right side, and less than negative 2 root 2, which is towards the left hand side. So my k will be greater than 2 root 2 or k less than negative 2 root 2. Okay, that is the final answer of the set of k values. Right, now for question 3. The variables t and x are related by the differential equation d squared x over dt squared plus dx dt plus x equals to t squared plus 1. So this is second order differential equation. Now A, find the general solution for x in terms of t. Alright, so now I will rewrite the question. Now, first of all, to solve the second order differential equation, we need to let the right side be 0. So I will let d squared x over dt squared plus dx dt plus x equals to 0. Then from here, the auxiliary equation will be m squared plus m plus 1 equals to 0. And now we need to get the m values. So obviously, this quadratic cannot be factorized. Therefore, we have to use the quadratic formula. So my coefficient for m squared is 1, which is the a is 1. My b is also 1 because that is a coefficient for m. Then the constant is 1. Alright, so now since your equation in terms of m, therefore, instead of x, right? So I'm using this formula. So x equals to minus b plus minus square root b squared minus 4ac over 2a. So I use the x here when the equation in terms of x. But now obviously your equation in terms of m. Therefore, instead of x in the formula, we need to change to m. So use by the same formula here, the minus b. So minus 1 plus minus square root b squared. So 1 squared minus 4ac over 2a. Alright. So from here, I will get minus 1 plus minus square root of 1 minus 4 is minus 3. Then over 2. Now, I can say that the square root minus 1 square root minus 3 is basically square root 3i. So here, minus half plus minus root 3 over 2i. So here I'm getting two complex roots. So with two complex roots, my general solution or my complementary function, okay, will be x equals to negative half. It should be e. Okay, now you refer back to your equation, right? Your differential equation is x in terms of t. Therefore, your complementary function here will be x in terms of t as well. So I will write x equals to e negative half t, which is my real part. Then multiply by a cos square root 3 over 2t plus b sine square root 3 over 2t. Okay, that is my complementary function. Right? So let me check. Okay. Now, after you have found this, then we need to refer to the right hand side. Since this is a quadratic, t squared plus 1, which means your trial solution, your x will be a quadratic as well. So, but then, since even though this function does not have the t, okay, so we still need to consider the general quadratic function, which is pt squared plus qt plus r. Alright, so now we need to differentiate two times because we have dx dt and d squared x over dt squared. So now differentiate two times. So dx dt, it will be 2pt plus q. Then d squared x over dt squared, it will be 2p. So I will let all this be second equation. And then my first equation is going to be the original question. So now to find all the unknowns in my trial solution, substitute the whole second equation into the first equation, which means the first term is d squared x over dt squared. So now I'm getting second, substitute into first. So dx squared over dt squared is 2b, then plus dx dt plus x. So dx dt is 2pt plus q, then plus my x is pt squared plus qt plus r, that equals to right hand side t squared plus 1. Okay, it's here. So I will get t squared plus 1. Now, to find the unknowns, right, so we can rearrange to group the coefficient for t squared, t followed by the constant. So from here, I will get pt squared plus 2pt and combine with the qt. Okay, then you will be getting t times 2p plus q. Then the rest of the terms will be the constants. So I get 2p, which is here, plus q plus r equals to t squared plus 1. Okay, so now by comparing the coefficients of t squared. So when I compare t squared, left hand side is p, right hand side is 1 t squared, that means it's 1. So found the p. Okay, so then you can calculate you can compare the coefficient of t first in order to get the q. Because if you refer to the constant, you still have the q and the r, two unknowns. So now I compare with t, 2p plus q. Right hand side there's no t, that means it's 0. So from here, I replace my p value. It will be 2 plus q equals to 0. Hence, my q is minus 2. Okay, and then lastly, compare the constant. So when I compare the constants, left hand side I get 2p plus q plus r. Alright, and then equals to 1. Now, to get the r, just replace. You see here 2p plus q. That means it's 0. So I know that 0 plus r is 1. Therefore, my r is 1. Okay. So after you have found all this, there is a particular integral. So my x will be, just rewrite. Replace the unknown in your trial solution. That will be a particular integral, which is pt squared plus qt plus r. So my p is 1. So 1t squared plus qt. Your q is minus 2. So minus 2t plus r. R is 1. Okay. And then lastly, general solution. That is x equals to complementary function plus particular integral, which means my x is going to be just a combination of these two results. Right, CF and the PI. So I will rewrite, it is e negative half t a cos square root 3 over 2t plus b sine square root 3 over 2t, then plus the particular integral t squared minus 2t plus 1. Okay, so that is the solution of this question. Right? So now B, deduce the approximate value of d squared x over dt squared for large positive values of t. So you must understand that large positive values of t means when the t tends to infinity. But now we are approximating the value for d squared x over dt squared. Just now we have found the x value. So now I need to differentiate 2 times and then approximate the value when the t tends to infinity. Alright, so I'm going to rewrite this x expression. So now my x is e negative half t a cos square root 3 over 2t plus b sine square root 3 over 2t, then plus t squared minus 2t plus 1. So plus t squared minus 2t plus 1. Alright, so now we need to differentiate 2 times to get the d squared x over dt squared. So now my dx over dt. So now for the first part, this is u, this is v. So we need to apply the products rule in order to differentiate this. So I keep the e. Alright. differentiate cos is negative sine. So then write negative sine first, square root 3 over 2t. Then when you differentiate, square root 3 over 2t is square root 3 over 2 together with the a. So I will direct write here, square root 3 over 2a. So that is how we differentiate it. Then for the b, when you differentiate sine, it is plus. So plus cos. Then square root 3 over 2t. So when you differentiate square root 3 over 2t, it will be square root 3 over 2. And combined with the b, it will be square root 3 over 2b. Okay, so from the products rule, keep the first, differentiate second. Now you keep the second. So I write plus. I will rewrite my a cos root 3 over 2t plus b sine root 3 over 2t, and I differentiate exponential. So when I differentiate exponential, it will be rewriting the exponential function and differentiate the power of e. So when differentiate negative half t, it will be negative half. Now, don't forget, you still have the quadratic at the back. So when differentiate quadratic, it will be plus 2t minus 2. Okay, so this will be the dx dt. Alright, I'm not going to simplify it. I will just direct find d square x over dt squared, because our main concern is the d squared x over dt squared. Now again, for the first, alright, so this is u, here is v. So then this is u, the next one is v. So it means that we need to apply the products rule twice. So again, keep the first, which is the exponential. Now differentiate minus root 3a sine. So differentiate sine is cos. So square root 3 over 2t. Then differentiate square root 3 over 2t is going to be square root 3 over 2. So combine with the existing negative square root 3 over 2 means that you square the square root 3 over 2. So I will get negative 3 over 4. Okay, now for the next one, differentiate cos, it will be negative sine. So I will write negative sine root 3 over 2t, and then the root 3 over 2 combined with the root 3 over 2b, it becomes 3 over 4b. Okay, and then plus, just now I keep the e and differentiate the bracket. So now I copy the bracket and differentiate the e. So now I copy the bracket and differentiate the e. So when I differentiate exponential negative half t, it will be exponential negative half t. Then differentiate negative half t, it will be negative half. Okay, I get these two terms when I differentiate the first one. Alright, so now same for the next part. So again, another products rule. So keep the whole bracket. And differentiate negative half, which is here, negative half exponential. So when we differentiate exponential, rewrite, then this result, okay, when you differentiate here, is going to be negative half. So this negative half combined with the negative half, it becomes positive 1 over 4. So I will get 1 over 4 e negative half t. Okay, now I need to, just now I keep here, differentiate the exponential. So now I keep the exponential. So plus, I keep the exponential. And differentiate this, right, here. So it means that now when I differentiate cos, it will be negative sine root 3 over 2t. So when you differentiate root 3 over 2t over here, that means you are getting root 3 over 2 together with the a. So I will get negative root 3 over 2a. Okay, and same for the next one. When you differentiate sine, it will be cos. So I will write cos root 3 over 2t. Then differentiate root 3 over 2t is actually root 3 over 2. Combine with the b, you will get root 3 over 2b. Okay, so done the first two differentiations. Now, don't forget, you still have two more terms at the back. So differentiate 2t minus 2 is going to be 2, positive 2. Alright, so this is what we get. Okay, so now from here, the question says large positive values of t, means that t tends to infinity. So what happened to this? Approaches a value. What is that value? So now, we will just make the conclusion. Your t tends to infinity. So exponential negative half t tends to 0. So when this tends to 0, which means here 0, this is 0, here is 0, this is also 0. Means that 0 times the bracket will be 0. So first four terms will be 0. Then our answer just left the last term. D squared x over dt squared will tend to 2. Okay, so that's the solution for this question. Right, so now question 4. The diagram shows the curve with equation y equals to 2 power x. So this is a graph. Means this is y equals to 2 power x. For x from 0 to 1, so here is 0, this is 1. Together with a set of n rectangles, each with width 1 over n. So that means this is the first triangle, first rectangle. First rectangle, this is a second rectangle, this is going to be the n rectangle. Alright, so now from here, this is the n rectangle, the width is 1 over n all the time, so here is 1 over n. That's why 2 over n minus 1 over n is 1 over n. This will be the width. Here is 1 over n. Now A, by considering the sum of the areas of these rectangles, show that the integration of 2x dx from 0 to 1 is less than un, where un is this. Right? So now for your information, when you solve this integration, it's actually the area under the graph. Okay, so it means that you are counting area under the graph. So all of this. But then when you look at the diagram, since now you are drawing the triangle, a rectangle, so obviously when you consider the sum of the areas of all these rectangles, which means you will have extra here. Okay, which means all this, right? So therefore, from here we know that the area under the curve, which is this integration, is always less than the total area of rectangle here. It's just that now we need to show the total area of rectangle is this value. Okay, is this expression. Alright, that's the idea to solve this whole question. So now, I will start with total or sum of the areas of the rectangles first. So, sum of the areas of n rectangles, let it be un. So from here, I know that un, the area of rectangle is easy. It is the width times height. Okay, this is the height for the first rectangle. So now, by looking at the equation of the curve y equals to 2 power x, this x value is 1 over n. That means this y value is going to be 2 power 1 over n. Okay, so the area of the first rectangle is 1 over n, which is our width. The height is 2 power 1 over n. So I will write 1 over n times 2 power 1 over n. That is my area of the first rectangle. Now, for the second rectangle, since the x is 2 over n now, okay, second rectangle means 2 over n, then now here is going to be 2 to the power 2 over n, because it is 2 power x. Alright, so your x must change accordingly. So again, the width is 1 over n. Therefore, the area of rectangle for this second rectangle is basically 1 over n times 2 to the power 2 over n. So So from here, if you can see the pattern of that, so always 1 over n all the time. So I have plus dot dot dot. The last one is going to be 1 over n. Now for your information, the last rectangle, okay, the height of last rectangle, this is going to be 2 to the power of, this height is 2 to the power of this 1, alright? This 1 I can change to n over n, because I noticed that, see, when it is first rectangle, the height is 1 over n, right? Here is 1 over n. We follow this coordinate, right? When ordinate, I would say ordinate. So for second rectangle, the height is following this, right? 2 power 2 over n. So for last rectangle, instead of 1, I will change to n over n, because this is same as n over n. Okay, so I will write 2 to the power of n over n instead of 1, because I need to get this. So from here, the 1 over n is in common, therefore I may factorize 1 over n, and then I will get 2 to the power of 1 over n plus 2 to the power of 2 over n plus until 2 to the power of n over n. Okay, so from here you will notice that this is basically geometric progression. So this is geometric progression or geometric series, I would say series. So now your first term, a is 2 to the power of 1 over n. Then the common ratio, the r, is going to be division. So 2 to the power of 2 over n divided by 2 power 1 over n. So when it is the same base, you minus the degree. So 2 over n minus 1 over n is 1 over n. Alright, so now from here, it is a sum of first n terms. So now I will get Sn. Okay, just for this part. So it will be Sn equals to, because Sn is because of first term is numerator 1, second term numerator 2, last term is n. Therefore, first term to n term, it will be n terms in total, or n rectangles. So the formula for Sn is, I will say Sn is a bracket Rn minus 1 over R minus 1. So now Sn becomes, my first term is 2 to the power of 1 over n. Then R is 2 power 1 over n minus 1 over 2 power 1 over n minus 1. Okay. So now I will simplify this first. So this is going to be, okay, now careful with this. This r is 2 power 1 over n, right? This r. But then I forgot to write the n. How many terms? There will be n terms. Okay, so from here I will simplify 2 power 1 over n. Then when you simplify this, degree n of 1 over n, again we use this formula, a m power n, it will be a m n. So this means that these two can be multiplied. So I will cancel off to get 2 degree 1. So when 2 degree 1 minus 1, right, you will be getting just 1 in the bracket. So I will get 2 power 1 over n divided by 2 power 1 over n minus 1. This is my Sn. Sn means just this bracket. But don't forget your un has 1 over n outside. So from here, I will say my un, okay, so I continue here. My un is 1 over n of my Sn. Therefore, I will get 1 over n of 2 power 1 over n over 2 power 1 over n minus 1. Okay, so now if you compare, so my n should combine with 2 power 1 over n minus 1. So therefore, I just combine 2 to the power 1 over n divided by n bracket 2 1 over n minus 1. Okay, that is my un. But then now I want to show that this is less than un. So just by writing from the graph, area under the curve is less than the sum of the area of n rectangles. Okay, therefore integration from 0 to 1 2 power x dx is less than un. So where un equals to this term. Alright, so this will be the working of this whole question. Right? So now B, use a similar method to find in terms of n a lower bound Ln for this graph. Okay, so just now we know that your area of the area of the graph is less than the un, means that the un is the upper bound. Now we need to find the lower bound, means that the graph is actually bigger than this value. I mean this integration is bigger than Ln. So how could it happen? So now for the Ln, we cannot refer back to this graph anymore, but I will have to refer to another rectangle. Right? So now for your information, the rectangle is going to be here. This is my first rectangle. Second rectangle is here, so that it will be lower bound. And rectangle is here. Okay, this will be the height. Then here will be the height, and this is going to be the height. Alright, so from here, if you refer to the green color now, obviously the area of the sum of the area of the rectangle will be always less than the area of the graph. That's why the total here will be the total of the area of rectangle becomes the Ln, the lower bound. Okay, so please take note on the height now. So when you refer to the height, so now we are referring to the first ordinate of the rectangle. Just now we refer to the second ordinate. Okay, so now no more second ordinate, but we refer to first ordinate. So now for the first value, here is 1 because it is 2 power 0. Look at the graph. The graph is 2 power x. So now we are referring to x equals to 0. So the first one is 2 power 0, and then the second one will be this height is going to be 2 power 1 over n because we are referring to the first ordinate. And then same for the last rectangle, or the nth rectangle, it will be 2 power n minus 1 over n. Okay, so just redo the steps in A to get the Ln, right, by changing the heights. So now my Ln will be sum of, no need to define, right? So I will just direct find 1 over n. The first one is going to be 2 power 0, right? The second is 2 power 1 over n. So here 2 power 0 plus 1 over n, 2 power 1 over n, plus until 1 over n times 2 power n minus 1 over n, the previous ordinate. So again, the 1 over n is in common. You can factorize it. So the 2 power 0 you can change to 1 plus 2 power 1 over n plus, if you want to see clearly, 2 power 2 over n plus until 2 power n minus 1 over n. Okay, and again, this is the geometric series. So geometric series, right? Your first term is 1. Now your r is 2 to the power 1 over n divided by 1. So it is 2 power 1 over n. Okay, and still have n terms here because we still have n rectangles, right? The number of rectangles remain the same. So from here, I will say that this is going to be 1 over n. Use the same formula, right? So our formula is a r power n. This is my r. Then power n minus 1 over r minus 1. Use back the same formula as just now, okay, which is this. Alright, so now simplify. So again, the degree n can be cancelled off. Then I will get the numerator. This is basically 1 bracket 2 minus 1 over n bracket 2 power 1 over n minus 1. So you will get 1 over n bracket 2 power 1 over n minus 1. Okay, so that is your ln. Right? So now see, find the least value of n such that un minus ln is less than 10 power negative 4. So now we need to find least value of n. So un minus ln less than 10 power negative 4. So now substitute the un and ln expression. So your un is 2 to the power 1 over n bracket 2 power 1 over n minus 1. Okay, so 2 power 1 over n over n bracket 2 power 1 over n minus 1 minus the ln is 1 over n bracket. So 1 over n bracket 2 power 1 over n minus 1 less than 10 power negative 4. So now you need to solve this inequality. So you will notice that the numerator, the denominators are the same. So just rewrite, combine the denominators, then numerator becomes 2 power 1 over n minus 1 less than 10 power negative 4. Okay, so now you should realize that the numerator can be cancelled off with the denominator. So now 1 over n less than 10 power negative 4. And now we need to get least value of n, which means what is the n? This n move up. Alright, so now my n is greater than 1 over 10 power negative 4. So I continue here. Therefore, my n is greater than 10 power 4. 10 power 4 means the n is greater than 1000. Alright. Sorry, it's 10,000. Okay, so from here, n is greater than 10 power 4 means n is greater than 10,000. Therefore, your least n is 10,001. Alright, so that's the answer for last part. Alright, so now for question 5. The variable x and y are such that y equals to 0 when x equals to 0, and you are given this equation. Show that dy dx is negative 3 over 4 when x equals to 0. So first of all, I rewrite the equation. Now to get the dy dx, you can just direct differentiate the implicit equation. So the first one, we are going to apply product rule. This is uv. So keep the x plus 1, differentiate y with respect to x is dy dx. Plus keep the y, differentiate x plus 1 is 1. And now for the next term, bring down the 3, rewrite the whole bracket, and then degree is 2. Differentiate x plus y. So differentiate x is 1, differentiate y is dy dx. Then differentiate plus 1 is 0, close bracket, equals to right hand side when differentiate 1 is going to be 0. Okay, so now we need to show that x equals to 0, then dy dx is negative 3 over 4. But then when you look at this equation, okay, other than dy dx, we have the x, we have the y. So don't forget, when x equals to 0, your y also 0. So I will write x equals to 0, y equals to 0. So now replace. So 0 plus 1 dy dx plus 0, second term, plus 3 bracket 0 plus 1, because x and y equals to 0, squared, 1 plus dy dx, that equals to 0. So now, for the first term, it becomes dy dx. Second term, just ignore it. Then the third term, you will get 3 times 1 plus dy dx. So I will do the expansion. So I will get 3 plus 3 dy dx equals to 0. Okay, so now dy dx plus 3 dy dx is 4 dy dx. Then the plus 3 will be moved to the other side, becomes minus 3. Hence, your dy dx will be negative 3 over 4. So now we have shown the result. Okay, so part B, find the Maclaurin series for y up to and including the term in x squared. So for Maclaurin series, right, so we need to differentiate. So now, since this is x squared, in terms of x squared means that you need to differentiate 2 times for the y. So now I'm going to copy my dy dx here. I'm going to copy this. Right, you can simplify this, otherwise you can just rewrite this before you differentiate. So I will going to copy this. So I will write x plus 1 dy dx plus, okay, here y times 1 is y, then I will copy these terms equals to 0. So I will write down all the terms now. So plus y plus 3 bracket x plus y plus 1 squared, then 1 plus dy dx equals to 0. And now I'm going to differentiate this. Okay, so again, when you differentiate, the first is uv, then here is u, this is v. Again, now, products rule, keep the first, differentiate dy dx is d squared y over dx squared, plus, keep the dy dx, differentiate x plus 1 is 1. Done the first differentiation. Now, when differentiate plus y, it's going to be plus dy dx. Okay, now the next is, I treat this as u, and this bracket is v. So again, from the products rule, keep the first. So I'm going to copy all these terms as my u. Differentiate the v. So differentiate 1 will be 0. Differentiate dy dx is d squared y over dx squared. Now, again, plus, keep the 1 plus dy dx, keep the v, and differentiate the u. So when you differentiate the u now, okay, these two will be multiplied with 3. So here becomes 6 plus 6 bracket x plus y plus 1 degree 1. And then don't forget to differentiate the bracket, this bracket. So when you differentiate x is 1, then plus differentiate y is dy dx. Differentiate 1 is 0. Okay, so right hand side equals to 0. Because when you differentiate 0, it's still 0. Now I get these two expressions. So basically, your dy dx already found, negative 3 over 4. Okay, so now I need to find what is my d squared y over dx squared in this whole expression. So my x equals to 0, y equals to 0, my dy dx is negative 3 over 4 from the previous solution. So now you replace all these values into this equation. So I will get 0 plus 1 is 1. Oh, I do step by step. d squared y over dx squared plus dy dx is negative 3 over 4. Okay, times 1 is still the same. Then plus another dy dx means I times 2. Then plus 3. 0 plus 0 plus 1. So 0 plus 1 squared. D squared y. Rewrite. then plus 1 plus dy dx, 1 plus negative 3 over 4, then plus 6, 0, 0, 1. So it's 0 plus 1, degree 1. Then 1 plus dy dx is negative 3 over 4. So negative 3 over 4 equals to 0. So now further simplify. The first term is d squared y. So I will get d squared y over dx squared. Then the second term is going to be negative 3 over 2 when you simplify. Then the next term is 3d squared y over dx squared. When you simplify this, it is plus 1 over 4. Okay, I think I made a mistake because this 1 plus dy dx. Okay, let me check the working here. Okay, now I need to explain one more time for this. Keep differentiate, so keep differentiate plus keep dy dx, differentiate x plus 1, which is 1. The differentiate y is dy dx. So for this, I keep this, so I keep this, and differentiate 1 plus dy dx, which is here. Now I keep the second, alright, I keep the second and differentiate this. Okay, correct. I with a plus keep this and differentiate this part. Then now I have to keep this 1 plus dy dx and differentiate. So there's a plus. This one shouldn't have plus. It is multiply. Okay, a small mistake over here because it is product rule. So you keep 1 plus dy dx and then you times by differentiation of this. So when I differentiate, I move down the 2 becomes 6. There's no plus. So it means that in this working, okay, so it should be 1, 2, 3, 4. So 1, 2, 3, 4. And then 1, 2, 3. So okay, here 4. Then this 1 plus this multiply. Okay, mistake. This should be the multiplication. It's not plus. So which means, right? So 1 plus negative 3 over 4 is 1 over 4. So multiply by all of this. So I multiply by 6. Then 1 minus 3 over 4 is 1 over 4. I should get this. That equals to 0. Alright. So sorry for the small mistake. So shouldn't have plus, but it's just times. Right. So my working supposed to be times. Okay, here supposed to be times. Alright, so now from here, my d squared y, I need to get the d squared y value. So combine these two, it will be 4 d squared y over dx squared. So when you simplify, it will be 3 over 2. This whole term you move to the other side is 6 over, okay, I simplify first. So here is 3, here is 2. So it means that 3 over 8. So it's minus 3 over 8. Alright, so you will get 8. This is 4 times 3 minus 3. So 12 minus 3 is going to be 9 over 8. Therefore, your d squared y over dx squared is 1 over 4 times 9 over 8, which is 9 over 32. So we have found the d squared y over dx squared. Now, with this, we can form the Maclaurin series. So now Maclaurin series of y. So y equals to y0 plus dy dx, where the x, or I will say that y prime. Okay, I don't want to use y dy dx. I use y prime. That will be better. Y prime 0 times x plus y double prime 0 times x squared over 2 factorial plus dot dot dot. That is the Maclaurin series. Okay, but then when you refer to the question, it's mentioned that including the term in x squared. That's why we stop at the d squared y over dx squared. Now, y0 means the y value when x equals to 0. So, when you look at the question here, right, when x 0, your y is 0. Therefore, I will write 0 plus y prime 0 means the dy dx value when the x equals to 0. So just now the dy dx value we have found negative 3 over 4. So I will get negative 3 over 4 multiplied by x. Excuse me. Plus y double prime is going to be 9 over 32. Then x squared over 2 factorial. Now lastly, write down the final answer. So the 0, ignore it. Plus minus 3 over 4x is negative 3 over 4x. Then 9 over 32 times 1 over 2 factorial. It becomes 9 over 64 x squared. So this is your Maclaurin series of y. Right? So now, next question, number 6. Use the substitution y equals to vx to find the solution of the differential equation. So this is first order differential equation for which y equals to 0 when x equals to 1. Give your answer in the form y equals to fx, where fx is a polynomial in x, 10 marks. Okay, so let's check the, okay, a lot of space is given. So now, let me rewrite the question first. Okay, you are given the hint. Use substitution y equals to vx. So now we need to start with y equals to vx and then we replace the y by vx. So now I will do it side by side. So y equals to vx. But then here we have dy dx, means that we need to differentiate. Again, this is v times x, which is the product rule. So now dy over dx is, keep the v, differentiate x with respect to x, you get 1. Plus keep the x, differentiate v with respect to x, it will be dv over dx, which means your dy dx is basically v plus x dv over dx. That is your dy dx. So now I will replace. So I will get x bracket v plus x dv over dx equals to your y equals to vx. So vx plus square root 9x squared plus y squared. So from here, y squared is going to be v squared x squared. I will direct write v squared x squared. Okay, so from here, right hand side, vx plus, inside the square root, the x squared is in common, which means I can factorize the x squared, 9 plus v squared, both in square root. And then I can split it into two terms. So the square root x squared becomes x. Then multiply by square root 9 plus v squared. Okay, and again for the right hand side, the x is in common. Therefore, I can further factorize the x. So I will get v plus square root 9 plus v squared. This is what I get at this moment. Okay, but then if you notice, the x appears on the left and right side. So I can cancel off these two x. Alright, so now the simpler form becomes v plus x dv dx equals to v plus square root 9 plus v squared. And then again, you have the v both sides, so the v can be cancelled off. So now I cancel off the v. That means the simplest form of the first order differential equation becomes x dv dx equals to square root of 9 plus v squared. Okay, so now we need to solve this first order differential equation using separable variables. So I will keep all my v on the left hand side because of the dv on top. So now dv, this whole right hand side is a function of v, so I will move it to the left hand side. So it becomes 1 over square root 9 plus v squared. And then the x from the left hand side will be moved to the right hand side, becomes 1 over x, then dx. So once you move, remember to add on the integration sign. That is the separable variables. Now, for the left hand side, to integrate 1 over square root of 9 plus v squared dv, you need to refer to this formula. Integrate 1 over square root of a squared minus x squared dx. This is inverse sine x over a plus c. So when you compare, okay, so the 9 becomes 3 squared. If you want to see clearly, so I will change to 1 over square root 3 squared plus v squared dv equals to integrate 1 over x dx. So obviously now your a is 3. Okay, that means I'm getting arc sine v over 3 because I'm integrating with respect to v. So left hand side is arc sine v over 3. Okay, now for the right hand side, when you integrate 1 over x, that is the ln. So ln x plus c. Okay, so before we proceed, right, to get the solution where y equals to fx, you need to refer back. Your y is vx, and now you are given x and y. Alright, so I will write x equals to 1, your y equals to 0, then y equals to vx. Now we need to get the x, we need to get the v here in order to get the c, which means your v is y over x, which is 0 over 1 and also 0. So now I know that my x equals to 1, my v is 0. Okay, so substitute these two values into the previous solution here to get the c. So I will get inverse sine v over 3, so 0 over 3 equals to ln, the x is 1, plus c. So for your information, sine inverse sine 0 is 0. Okay, so this is 0. Ln 1 is 0, which means the c is 0. So which means c is 0. So now I will rewrite, okay, or I will substitute my c equals to 0 into this expression. So I will get inverse sine v over 3 equals to ln x. Alright, so now you are getting this. So if you want, you can change back the v to y over x, but again you will get the inverse sine. Okay, so what I will do now here is, instead of leaving your answer in this form, according to the question you must get the y as a subject, no more sine or no more inverse sine. So now we need to refer to the inverse sine expression. Inverse sine x is ln x plus square root of x squared plus 1. Okay, so now my x becomes v over 3. So therefore I will get ln of v over 3 plus square root of v over 3 squared plus 1 equals to ln x. So once you get this, I can cancel the ln from both sides. And then now I will change my v to y and x. So which means v is y over x. So this is y over x, then multiply by 3, so it becomes 3x. plus square root y over 3x squared plus 1 equals to x. Okay, so now we just need to get the y as a subject. So now, for the square roots part, I will get the same denominator first. So I will be getting square of 3x is 9x squared. Then y squared plus, I get the same denominator for the 1, which means it's 9x squared. That equals to x. Right, so from here, I will get y equals to 3x, y over 3x plus, remember the square root of division, it will be square root a over square root b. So the square root 9x squared, I will change to 3x. Then the numerator, I will just copy. That equals to x. Now, since the denominator is the same now, 3x, 3x, so I can just combine these two denominators and move it to the right hand side. Or you can say you multiply the whole equation by 3x. Okay, so y plus square root of y squared plus 9x squared is going to be 3x squared. Right, now, again, you need to leave your answer in y equals to fx. So now I need to eliminate the square root. So I have to move the y to the right hand side. Right, so I will rewrite here square root y squared plus 9x squared is 3x squared minus y. So after that, my next step is going to be square both sides. So once you square both sides, the left hand side square and square root will be cancelled off. Okay, so I will be getting y squared plus 9x squared. Right hand side, you need to do the expansion. So a minus b squared, use this formula. Quadratic expansion. It will be a squared minus 2ab plus b squared. So now I will get 9x degree 4 minus 3x squared minus times minus y times 2. So minus 6x squared y, then plus y squared. Okay, and then from here you will notice that you get the y squared both sides. So these two y squared can be cancelled off. And then I keep this as one term or on one side. So I will move it to the left hand side. And then the 9x squared will be moved to right hand side. So 9x degree 4 minus 9x squared. Right, so now my y, because we need to get y. So for the right hand side, the common term is 9x squared. I may factorize the 9x squared, bracket, x squared minus 1. Then the 6x squared will be moved to the right hand side. Okay, so at last, the x squared will be simplified, will be cancelled off. Then 9 and 6 will be 3 over 2. So I will get 3 over 2 bracket x squared minus 1. So this is my solution for this whole question. Okay, now question 7a. Use the De Moivre's theorem to show cosec 7 theta equals to this expression. So we know that cosec is 1 over sine. Alright, so I will start with sine 7 theta. So sine 7 theta is the imaginary part of cos 7 theta plus I sine 7 theta. So according to De Moivre's theorem, this is same as cos theta plus I sine theta to the power of 7. Okay, so instead of writing cos theta plus I sine theta, I will let it be C for cos and S for sine. Alright, so I will define here first, then it will be easier. So now, for degree 7 of C plus IS, I'm going to use the binomial expansion. So binomial expansion, first term, C power 7, then 7, 1, or you can write 7C1 up to you. So but then I do not use the C here because you have the C for cos already. So that's why I used this symbol. So C degree 6, IS degree 1, plus 7 C2, C degree 5, IS degree 2. Okay, so continue this until is degree 7. So C degree 4, is cube. This is what we are getting. Okay, so this is the full expansion that you get it from binomial expansion. So now we need to simplify. So here I will write equals to Im C7. 7 C1 is 7. So 7 C6 IS1. So means that I will write IS. Then now you have to be careful. This I, when you bring in the square, it is I squared. So I squared is minus 1. So I will direct simplify now. It will be minus 7 C2 is 21. So I get C5, C degree 5 as squared. The minus because of I squared is minus 1. So now when I bring in the cube, so you have to check here. I squared is minus 1. I cube is going to be I squared times I, which is minus 1 times I will get minus I. Okay, so this I cube I will change to minus I. So 7C3 is 35. Okay, so together with this minus I, it will be negative 35 C degree 4 S cube I. Then I degree 4. So when you consider I degree 4 here, I degree 4. So I degree 4 is square of I squared. So I squared is minus 1. So square of minus 1, I will be getting 1. Alright. So then 7C4 is going to be 35. So I will get plus 35 C cube S degree 4. Okay. So now I degree 5 is I degree 4 times I. So therefore this is 1 times I will get I. So now 7C5 is 21. And it is plus 21 C squared S5 I. Because this is I here. Then I degree 6. So I degree 6 is basically I degree 2 power 3. So minus 1 degree 3 is minus 1. So then 7C6 is 7. So I will get negative 7 C S degree 6. Okay, lastly, I degree 7. So now from here, I degree 7 is going to be I degree 6 times I. So I degree 6 is minus 1. So minus 1 times I, at last I get minus I. Right? So, which means I S degree 7 is minus S degree 7 I. So this is how we simplify it. And from these 8 terms, we are just interested in the imaginary parts. So it means that imaginary parts will be the terms with the I. In other words, I will just take this, okay, and then take all this, will be the coefficients of I lah then. So take this and take this. That will be my imaginary parts. So I will write, this is 7C6S minus 35 C degree 4 S cubed plus 21 C squared S degree 5 minus S degree 7. This is going to be my sine 7 theta. Okay, so now I can change back my C and S to be sine and cos, right? So I will rewrite, this is cos degree 6 theta sine theta minus 35 cos degree 4 theta sine cube theta plus 21 cos degree 2 theta sine degree 5 theta minus sine degree 7 theta. Okay, but then when you refer to the question here, I need to get cosine for my final answer. Okay, cosine means 1 over sine. No other terms. All must be 1 over sine. Which means, okay, you have to change all the cos to sine. So now, how to change the cos to sine? You need to refer to cos squared theta plus sine squared theta is 1, which means cos squared theta is 1 minus sine squared theta. Okay, replace the cos squared theta by 1 minus sine squared theta. So this cos degree 6 theta is basically cube of cos squared. So I will write 7 sine theta, then cube of cos square. The cos square I change to 1 minus sine squared. So 1 minus sine squared theta. Okay, then minus 35 sine cube theta. Then cos degree 4 theta. Cos degree 4 theta is square of cos square. So the cos square here will be changed to 1 minus sine squared theta. Okay, then plus 21 sine degree 5 theta. Then multiply by cos squared theta. Cos squared theta is 1 minus sine squared theta. Lastly, we write. So now we have to simplify. Do expansion first. So the cube, okay, for this cube, alright. So if you still remember Pascal triangle, degree 1, here is 1, 1. If it's degree 0, the coefficient is 1. So when it is degree 2, A plus B, degree 2, 1, 2, 1. How to get the 2? Plus together. So now we are expanding degree 3, means add the 1 in front and at the back. So plus together 3, plus together is 3. All these show the coefficients for the terms. Alright, so with this, I can easily get my expansion for cube of 1 minus sine squared theta. So I will get 7 sine theta. Then it's going to be 1, because here is 1. It is degree 3, plus the coefficient is 3. So 1 squared, then minus sine squared theta. Okay, plus the next coefficient is 3. So 3, 1 degree 1 minus sine squared theta degree 2 plus negative sine squared theta degree 3. Because the coefficient is 1. So I will just direct write plus 1 here. No need to write the 1. So that is my first expansion. Then minus 35 sine cube theta. And the next one is square this. Alright. So this is the quadratic expansion. So when quadratic expansion means that you will be getting 1 minus 2 sine squared theta plus sine degree 4 theta. And then lastly, the next term, okay, plus 21. Here you can just do expansion. Alright, this one you can just do expansion, direct expand. So I will get 21 sine degree 5 theta times 1 is sine degree 5 theta. Then 21 sine degree 5 theta times negative sine squared theta. It will be negative 21 sine degree 7 theta. Then lastly, negative sine 7 theta. Sine degree 7 theta. Okay, now you need to simplify. So 7 sine theta. 1 cube is 1. 3 times 1 squared times negative sine squared theta will be negative 3 sine squared theta. And then for this part, alright, the negative squared is positive. So I will get 3 sine degree 4 theta. Then next term, cube of negative sine squared theta. So it will be negative cube is still negative. Sine squared theta, you cube it, it becomes sine degree 6 theta. So negative sine degree 6 theta. Close bracket. And then for the next one, we need to expand. Okay, I will just expand all together with the minus 35 sine cube theta. So I will get negative 35 sine cube theta. Then the next term is going to be plus 70 sine degree 5 theta. And then the last term will be negative 35. Sine cube, sine degree 4 becomes sine degree 7. Okay, and lastly, just copy or simplify these two terms. I will get plus 21 sine degree 5 theta minus 22 sine degree 7 theta. Okay, so now need to further simplify. So we need to do expansion right now. Just expand. So I will get 7 sine theta minus 21 sine cube theta plus, expand again, 21 sine degree 5 theta minus 7 sine degree 7 theta. Then now I will, rewrite this term, negative 35 sine cube theta. The degree 5 also rewrite because we cannot simplify with, no, you can simplify. Okay, so this 70 sine degree 5 theta together with this, you can simplify. So I will get 70 minus 22 is 48 sine degree 7 theta. Wait, I overlook it. Okay, because this is degree 5, so shouldn't simplify with this. Okay, I have erased this 21, 1, 2, 3, the third term is degree 5. Okay, so degree 5 should combine with this degree 5. Becomes 91. Degree 5. Okay, then for the 7, degree 7, it will be these two terms. So minus 35 minus 22, it becomes minus 57. Okay, so now simplify again. So I will get 7 sine theta. For the cube, right? Negative 21 sine cube, negative 35 sine cube. So it will be 56, negative 56. And then for the degree 5, when you simplify, 91 plus 21, it is 112. So I get plus 112 sine degree 5 theta. Okay, lastly, negative 7 sine 7 theta minus 57 sine 7 theta means that this is negative 64 sine degree 7 theta. Okay, so now don't forget that we are still finding sine 7 theta, but the question is asking for cosec. So now for cosec, it will be 1 over sine. Right, this is sine power 7 theta. Sorry, this is sine 7 theta. Okay, sine 7 theta, not power 7. So now to get the cosec, right, I will, oops. Okay, I have taken too much space. So never mind. So cosec 7 theta is 1 over sine 7 theta. So I'll take 1 over of all these terms. Now let's look at the question first. See, you need to get cos power 7, and then the 64 is at the back. Means that now I need to rearrange. Okay, so I will negative 64 is at the back, so I will just use this order. Okay, you take 1 inverse. But then how do I get cosec power 7? So cosec power 7 means that this is 1 over sine power 7 theta. Okay, so now when you look at the working here, I get only 1. It is not 1 over sine power 7, which means you need to times 1 over sine power 7 theta divided by 1 over sine power 7 theta. Okay, to this. Right. So now when I multiply, so look at here. When I multiply this to 1, my numerator is 1 over sine to the power 7 theta. Okay, so now I will write this is basically cosine power 7 theta, then over, now when 7 sine theta divided by sine to the power 7 theta, I will get 7 over sine degree 6 theta minus sine cube over sine degree 7 is sine degree 4 plus 112 over sine degree 5 over sine degree 7 is sine squared. Okay, then minus 64. Sine degree 7 over sine degree 7 is just 64, minus 64. Now, lastly, you can change the sine to the 1 over sine to cosine. So, which means now my cosine 7 theta is basically cosec 7 theta. So, here, maybe I will just continue here because of not enough space. So, cosec 7 theta is cosec to the power 7 theta over 7 over sine degree 6, it is 7 cosec degree 6 theta minus 56. Sine degree 4 1 over sine degree 4 theta is cosec degree 4 theta. Then 1 over sine squared theta is cosec squared theta. Then minus 64. Okay, so this expression is exactly same as the given form. 7 minus 56, 112 minus 64. Right, so we have done this proving. Right, now B, hence obtain the roots of the equation. So hence means use previous answer. So now I will rewrite. Our cosec 7 theta just now was cosec to the power 7 theta over 7 cosec power 6 minus 56 minus 56 cosec degree 4 plus 112 cosec degree 2 theta minus 64. Okay, so when you compare with this, alright, so now I notice that this 128 is double of this, 224 is double of 112, 112 is double of 56, 14 is double of 7. So how to get double? Means that the cosec 7 theta is 2. So I let cosec 7 theta be 2. So once I let this be 2, I need x. So it means that this is going to be my x, the cosec. Okay, all this, you see, 112 becomes 224, x squared. This is cosec squared. So it means that my cosec theta equals to x. Alright, so with this assumption, I will get my left hand side is 2. So my numerator is x degree 7. Then over 7 x degree 6 minus 56 x degree 4 plus 112 x degree 2 minus 64. Alright, so now I times all these terms to the left hand side. So then you will be getting all the the coefficients. So I will get 14 x degree 6 minus 112 x degree 4 plus 224 x degree 2 minus 128. So the double of 64 is minus 128 equals to x degree 7 because when I move up. So now you get the x degree 7 as first term. Means that you move all these terms, all the terms on the left hand side to the right side. So x degree 4 minus 14 x degree 6 plus 112 x degree 4 minus 224 x degree 2 plus 128 equals to 0. So this equation is exactly same as the question here. Okay, so it means that now basically I just need to solve cosine 7 theta equals to 2 if I need to solve this whole equation. Alright, so cosine 7 theta equals to 2. 1 over sine 7 theta is 2, which means sine 7 theta is half. Now I just need to solve this equation, then I will be getting the solution. Remember, your solution in terms of x, right, means that I need to get what is my cosec theta. That is my final answer of this question. So now, when you refer to the quadrant, sine positive, sine is half, means that it will be first two quadrants. So the basic angle is going to be pi over 6, which is 30 degrees. Here is pi over 6. So I know that my next angle is going to be 5 over 6 pi. So I will write 7 value, pi over 6, 5 over 6 pi. Then consider a complete cycle, means that pi over 6 plus 2 pi. So you will get 16 over 6 pi, 13 over 6 pi, then 17 over 6 pi, 25 over 6 pi. Just generate 7 values because of 7 theta. Then 37 over 6 pi. Okay, so your theta is going to be over, move down the 7. So all divided by 7 means that pi over 42, 5 over 42 pi, 13 over 42 pi, 17 over 42 pi, and 26 over 42 pi, then 29 over 42 pi, lastly 37 over 42 pi. Okay, but that is our data. Now remember, our solution is the x, because your equation in terms of x. So it means that our solution is x equals to cosec theta. So now you can just rewrite your x is cosec theta, which means your x is cosec of all of this. So cosec pi over 42, cosec 5 over 42 pi, cosec 13 over 42 pi, cosec 17 over 42 pi, and then cosec 25 over 42 pi, cosec 29 over 42 pi, and cosec 37 over 42 pi. Alright, so that's the solution for this question. Okay, so question 8. Find the value of A for which the system of equations, these are the system of equations, does not have a unique solution. So when does not have unique solution means that the determinant equals to 0. Okay, so from here we need to get the matrix first. So the determinant of the matrix will be 3, A, and 0. So 3A, 0, 5, minus 1, and 0. Then 1, 3, 2. Right? So now from here to get the determinant, I will fix the last column because there are two zeros. So the sign is plus, minus, plus. Because here is plus, here minus. Alright. So now I will just consider the last row now. So when I consider last row, the cross out is plus 2. So now I will write plus 2. The remaining terms 3A 5 minus 1 equals to 0. So from here, evaluate the 2 by 2 determinant. I will get negative 3 minus 5A equals to 0. So A cannot be 0, therefore negative 3 equals to 5A. So your A will be negative 3 over 5. So that's the solution for A. Now, second part. Given that A equals to 3, 0, 0, 5 minus 1, 0, 1, 3, 2. Okay, so let's check. So actually it's the same, you see. Here, 3, A, 0, 5 minus 1, 0. So that means that now your A is 0. Okay, so when A equals to 0 means that the it has unique solution. No, I will say just forget about it. Okay, so just refer to this A. Alright, so now find the matrix P and diagonal matrix D such that A square is PDP inverse. Means now we need to get the determinant. Alright, so basically the determinant is, I would say we need to find the determinant of the characteristic equation. We need to get the characteristic equation. Right, so it will be determinant A minus lambda I equals to 0. So since the I is the identity, means that when you multiply, okay, let me show step by step. It will be 3, 0, 0, 5 minus 1, 0, 1, 3, 2 minus lambda 1, 0, 0, 0, 1, 0, 0, 0, 1 equals to 0. Okay, so when you minus a lambda means that the diagonals will change to lambda. So what I do here is my diagonal for the matrix A will be minus lambda, the rest remain. Okay, and then now I will use the same concept as just now. Since this column 3 has 2 lambda, has 2 0, so I will start labeling. I will fix this column. So label here plus, minus, plus, and then I will consider the labeling for the row or the column that I have fixed. Right, that means this is 1. So here 1, 3, 2. And this is going to be plus. So now I fix a row. Okay, last row. So same as just now, right? So when you keep, it will be plus 2 minus lambda. That is a cross out. Then remaining terms 3 minus lambda 0, 5 minus 1 minus lambda equals to 0. Let me check the space. Okay, not much space given. So then from here, I will get 2 minus lambda, then cross multiplication. So 3 minus lambda times minus 1 minus lambda, then 5 minus lambda, 5 times 0 is 0. So you can just write minus 0 over here. So when you solve this, it's basically lambda equals to 2 because 2 minus lambda is 0, or 3 minus lambda is 0 means it is minus 3, or minus lambda minus 1 is 0 means that lambda is minus 1. So I'm getting 3 lambda here, means that I need to get 3 eigenvalues. Alright, so I will start solving the lambda on the right hand side because of not enough space. Alright, so I will just solve it here. So I will start with lambda equals to 2. When lambda equals to 2, right, we will substitute into this matrix. So I will get 3 minus 2. So it's 1, 0, 0. Right, remember, I will substitute into this matrix, change to matrix. So then 5 minus 1 minus 2 is minus 3, then 0. Then 1, 3, 2 minus 2, 0. Multiply by x, y, z equals to all zeros. We need to get the eigenvalues, eigenvectors. Okay, the eigenvector corresponds to this eigenvalue. So now, when you multiply first row, x equals to 0. Then the second row, when you multiply 5x minus 3y equals to 0. Since your x is 0, means that your y is also 0. Okay, then for the last row, you will get x and y only, there's no z. Therefore, you will let the z be any other number, let's say, any other parameter, let's say t. Then I will get my x, y, z as t. X is 0, so 0t, y is 0, 0t, z is 1, z is t means that it is 1 times t. So I will say that this is my lambda 1, then my eigenvector 1 is going to be 0, 0, 1. Okay, so we have to repeat the same steps for the next two lambda value. So now my next lambda, I'm going to show it here. My next lambda, let it be lambda 2, and it is 3. So now my matrix, so again substitute lambda equals to 3 into this matrix. First row will be 0, 0, 0 because 3 minus 3. Okay, then second row, 5 minus 1 minus 3, this value minus 1 minus 3 is minus 4. So I will get 5 minus 4 is 0. And then last row, 1, 3, 2 minus 3 is minus 1. So 1, 3 minus 1. Multiply by x, y, z equals to all 0. Right? So from here, first row, you won't get any equation. Then we refer to second row, I will get 5x minus 4y equals to 0. Then the third row, when you multiply, it will be x plus 3y minus z equals to 0. So to solve this, right, so I will, since first equation, you have x and y, so it means that I can let my y be s. You can let the x be any other parameter, no problem. So s equals to s, therefore 4y equals to 5s, which means my y is 4 over 5s. Okay, so now from the second equation, I will be getting my z. So my z move to the right side, it will be x plus 3y. So s plus 3y. So now I will get s plus 12 over 5s, which is 17 over 5s. Okay, let me check. S x plus 3y. So, alright, so s plus 3y. So, yep, correct. So from here, I will get my solution. So all in terms of s, x is 1s, y is 4 over 5s. Then the z is 17 over 5. Okay, so from here, I may factorize the 5. 1 over 5. So I'll get 5, 4, 17. Okay, let me check the working first. 5s minus 4y. When my x is s, 4y is 5s. Oh, okay, I made a mistake here. See here, 4y is 5s. My y is 5 over 4. Okay, not 4 over 5. This is 5 over 4. So here is going to be 5 over 4s. So here is 5 over 4. It is mistake. So here is 5 over 4s. So when you plus together, it is 15 over 4. So when I plus together, it becomes 19 over 4s. Okay, this should be the correct answer. Alright, so now my y is 5 over 4. Then my z is 19 over 4. So when you factorize 1 over 5, no more 1 over 5. It should be 1 over 4 then. When you factorize 1 over 4, so the first term is 4, second is 5, then is 19. So from here, I will say that my E2, second eigenvector, is 4, 5, 19. Okay, so now, same for lambda 3, which is minus 1. So lambda 3 is minus 1. So then, my matrix So when you substitute lambda by minus 1, it becomes 3 minus minus 1, 4. I will get 4, 0, 0 for my first row. So 4, 0, 0. Then after that, my second row is 5. Minus 1 minus minus 1 is 0. So 5, 0, 0. I will get 5, 0, 0. Then my last row will be, okay, 2 minus minus 1 is 3 for the last term here. So I will get 1, 3, 3. So here, 1, 3, 3. Then x, y, z equals to all zeros. Now, when you form the equation, the first equation, 4x equals to 0. That means your x is 0. Okay, then for the second row, it will be the same. 5x equals to 0. So your x is still 0. Then the third row, I will get x plus 3y plus 3z equals to 0. But since your x already 0, means that your y equals to minus z. Now I will let my z be u. Therefore, my y is minus u. So now my solution, you may factorize the u, so your x is 0, your y is minus u, your z is u. Therefore, my third eigenvector is 0, minus 1, 1. Okay, so after this, you have to refer back to the question. This is a squared equals to PDP inverse. A squared means that you have to square the diagonal matrix. So actually, the diagonal matrix consists of all the lambda values. But then now you have to square it. Okay, so now, final answer, the D is going to be square of the first lambda. So our first lambda is 2. So now, it will be 2 squared, 0, 0. Then my second lambda is 3. So 3, 0, 3 squared, 0. Then my last lambda is minus 1. So here's 0, minus 1 squared. This will be my D. So when I simplify, it will be 4, 0, 0, 0, 9, 0, 0, 0, 1. And the P will be the corresponding eigenvectors. So the first eigenvector is 0, 0, 1, which is here. So I will write 0, 0, 1. Then the second eigenvector is 4, 5, 19. 4, 5, 19. And the last eigenvector, 0, minus 1, 1. So this will be the final answer for the P and D. Right? So now, part C, use the characteristic equation of A to show this equation, where B is an integer to be determined. Okay, so the characteristic equation is basically determinant of A minus lambda I equals to 0. So basically, we have solved it just now, which is this, right? Here, and you are getting this now. So I will rewrite this. 2 minus lambda times 3 minus lambda times minus 1 minus lambda equals to 0. So 2 minus lambda, 3 minus lambda, minus lambda, minus 1 minus lambda. Equals to 0. Okay, so now we have to do expansion because you need to get all this. So when I do expansion, I will expand the first two brackets. So I will get 6 minus 2 lambda minus 3 lambda plus lambda squared. Then multiply by 1 minus lambda and let it be 0. So again, you further expand it. Right, just expand. Then you will get all these terms multiplied by 1, rewrite. Then all the terms multiplied by minus lambda. So increase the lambda degree by 1 and change the and multiply by negative. Okay, now you simplify. So I will get negative lambda cube. Then 2 lambda squared plus 3 lambda squared plus 1 lambda squared means that plus 6 lambda squared. Okay, then for the lambda, negative 2, negative 3, negative 6, then you will get negative 11. lambda. Okay, hang on, let me check the calculation, see whether I did a mistake. So, oh, okay, you see the minus here. I didn't write the minus. So I have to times minus to all these terms. Alright. So minus. Alright, so I will get minus lambda cubed, still the same. But then for the lambda squared, I will be getting minus lambda squared plus 2 lambda squared plus 5 plus 3 lambda squared. So 5 minus 1, 4. So I will get 4 lambda squared. Then for the lambda, I will get minus 6 lambda plus 5 plus 3 plus 2. So it means that it is plus minus 1 lambda. Okay. Then lastly, minus 6 equals to 0. Right. So now from here, let's look at here. We need 6i plus a. So it means that I should move these two terms to the right side. So I will get 6 plus lambda that equals to minus lambda cubed plus 4 lambda squared. Okay, so now all these are in lambda, means that the eigenvalues. But then when you look at the question, we need to change to matrix. Alright, so since the lambda is the eigenvalue for matrix A, so I can just change the 6 becomes 6i, change to matrix form. So I is the identity matrix, then plus A equals to minus a cubed plus 4a squared. Okay, but then when you look at here, this is a plus 6i. So I change first, a plus 6i equals to, okay, here you can factorize the a squared. Factorize a squared. Then now when you look at here, it is a. So I will rearrange, or probably I just remain this first and see what happened next. So again, when you factorize the a squared from the 4a squared, you should times I, so that it is a matrix. Right, when you look at here now, we need to get square of left hand side. So what to do? You just square it. So now square of a plus 6i, and then it will be square of the right hand side as well. Okay, so we get the same left hand side right now. This is a degree 4, which is bring in the square. This square, you bring it in, it will be a degree 4. And then it will be square of this bracket. Alright, so I will write negative a plus 4i squared. So when you check here, I need a plus bi bracket squared. So now from here, even though there's a negative, you can factorize a negative, then becomes a minus 4i squared. And now again, the squared, you bring it in. Okay, consider squared for both. So I will get a degree 4 minus square is positive. So I will get a minus 4i squared. Okay, so when you compare with the given form, a degree 4, a plus bi squared. So a degree 4, a plus bi squared means that the b is negative 4. Right, so I will write b is negative 4. So we have solved this question. Right. Okay, and also come to the end of the question paper. Alright, so thank you for watching this video. Remember to subscribe to my channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.